Welcome to class. In this video, we're going to discuss graphs, applications, and regressions of quadratic functions. So let's start by taking a look at the components of a quadratic function. A quadratic function, when graphed, will look like a U-shape, which is called a parabola. So a parabola has a few different key points. First of all, we have what's called the vertex. The vertex is going to be either the lowest or the highest point on the parabola. Then we also have what are called x-intercepts. These are going to be where they cross the x-axis. Parabolas tend to have two x-intercepts, but it's also possible for them to have one or none. So don't assume that they will have one. You'll just have to double check. Okay, so again, 0, 1, or 2 x-intercepts. Now, directly between the x-intercepts and intersecting the vertex is what we have called the axis of symmetry. And this is going to cut our parabola in half. It is going to be a vertical line, and therefore it's going to be written as x equals a number. In this case, we'd have x equals 1 because it goes through where x equals 1 at every point. Our last key point here is going to be the y-intercept. The y-intercept is where our parabola crosses the y-axis. So it's the same as when we talked about it as far as our lines went. Now, do notice here that across the axis of symmetry, if you're really confident in your axis of symmetry, you can always graph the rest of your parabola, because we have 5, 0, -3, 4, -3, 0, 5 as our y values. Because that's around the axis of symmetry, you know that you have graphed it correctly because it is creating a symmetric parabola. So take a look at this one and see if you can find the vertex, which should be a point, axis of symmetry, which should be the equation of a vertical line, zeros, which, remember, this is also the same thing as x-intercepts, and the y-intercept of the parabola. Once you've done that, you can press play on this video again. So here, our vertex is our lowest point, and it's going to happen at 3, 1. Our axis of symmetry is the vertical line that goes through the vertex that cuts our parabola in half, and it's written as x equals 3. If you just wrote 3, you are unfortunately incorrect, because you have to have x equals in order for it to be the equation of a line. 3 by itself means nothing. Okay, now the zeros, or x-intercepts, are where they cross the x-axis. Well, there are none because we are above the x-axis, moving upwards. So in this case, this is one of those situations where we have 0, zeros. Then our y-intercept is where we cross the y-axis, and that's going to happen right here. And you may be tempted to write 7, but y-intercept is a point, so it would be 0, 7. Always write that as a point. So the general form of a quadratic function, okay, general form, is f of x equals ax squared plus bx plus c. This means that if you see anything in this format, it is called the general form. Or if it asks you to put it into general form, we want it in this format. Now, a couple key points here. If a is greater than 0, that leading coefficient, then the parabola will open upward. If a is less than 0, the parabola will open downward. So this is going to tell us right away if we're talking about an upward parabola that looks like a U, or a downward parabola, which looks like a hill. Okay? If we have a function that's given to us in this format, we can calculate the axis of symmetry using the formula x equals -b over 2a. Remember, once you know your axis of symmetry, you also know the x value of your vertex. I'm going to go back to our previous example for just a moment. Look at this. We knew our axis of symmetry is x equals 3, and that aligned with our vertex's x coordinate. Okay? So when you know your axis of symmetry, this is going to be very helpful to you. Okay? So again, the formula when given in general form is x equals negative b over 2a. Then, to find the x-intercepts or zeros of the quadratic function that's given to you in this form, you're going to use quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. That should sound pretty familiar to you, hopefully, at this point. If it doesn't, feel free to look up quadratic formula, Pop Goes the Weasel, and watch that on loop. Okay, so this is going to give you the x-intercepts. Notice that they start with x equals, and those are going to give you either 0, 1, or 2 x values, but then your x-intercepts you do write as points. So go ahead and try to find the vertex, axis of symmetry, zeros, and y-intercept of this parabola. And once you've done that, go ahead and come back here to walk through it with me. So for me, I started by finding the axis of symmetry. To do that, I did x equals negative b over 2a, that formula we talked about before. In this case, that's negative 4 over 2 times 1. Negative 4 over 2 is negative 2. So my axis of symmetry is x equals negative 2. Again, don't forget your x equals. Now that you know the x value for your axis of symmetry, you also know the x coordinate for your vertex. So I'm going to plug negative 2 into my y function. So I have y equals negative 2 squared plus 4 times negative 2 plus 3. That's 4 minus 8 plus 3. That comes out to be negative 1. So my vertex is at negative 2, negative 1. Don't forget to write it as a point. Now our zeros happen when we are using quadratic formula, or you could also factor this by setting it equal to 0 and solve that way. I'll actually show you both ways really quickly. We'll start with quadratic formula because that is the way that they're expecting you to do. So we have x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. This is negative 4 plus or minus the square root of 16 minus 12 over 2. Negative 4 plus or minus the square root of 4 over 2. Negative 4 plus or minus 2 over 2. Now I can split my fraction and say negative 4 over 2 is negative 2. Plus or minus 2 divided by 2 is 1. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. So my zeros are negative 1, 0 and negative 3, 0. However, this was not actually the easiest way to do this problem. So if you chose to set this equal to 0, because remember what we're doing here when we're finding zeros or x-intercepts, is we're setting our y equal to 0 and solving, you would be able to factor this to be x plus 3 times x plus 1. And then you can see x equals negative 3 and negative 1. So you'll get the exact same answer, but it takes quite a bit less work, and they're just less, there are fewer opportunities to make a mistake. So if it's factorable, I really recommend going ahead and factoring it. It's just kind of easier. Last but not least is the y-intercept. The y-intercept is where you plug in 0. So I have y equals 0 squared plus 4 times 0 plus 3. That's 0 plus 0 plus 3, which is 3. So my y-intercept is 0, 3. Hopefully you got all 4 of those. And if you didn't, just remember that this might be something that you want to practice as you're going into your homework. So when we take a look at this graph, you can see that this does indeed give us the correct vertex and our x-intercepts and our y-intercept and our axis of symmetry. So when we look at the graph of this equation, you're going to find that we had all the correct answers. Now, Remember that your graphing calculator is a way to help check your answers. It is not a way to get your answers. But you are welcome to put this in your graphing calculator now, and you can check that these are correct values. Remember that on your tests, you are expected to show your work, and so you can't just, magically come up with an answer. You have to show how you're getting it. All right, so let's talk about the standard form of a quadratic function. This is also known as the vertex form. I will generally call it the vertex form because that is the way I was taught, but it is again also known as standard form. It is going to be f of x equals a times x minus h squared plus k, where hk is the vertex. Okay, this is a really helpful form because you already know the vertex because it's already put into a format that makes it easy to identify. And once you know your vertex, you also know your axis of symmetry, and so that makes it quite a bit easier. So for example, let's say we have y equals -3 times x plus 2 squared plus 4. What is the vertex in this case? Well, hopefully you're getting the idea that it's -2, 4. Because if you look here, we have x minus h squared, and x plus 2 here is really x minus -2, okay? So what's happening there is the negative is what's going to be included. So whatever your sign is inside the parentheses, the opposite is going to tell you the sign of your vertex for your x coordinate. Your y coordinate, the k, is going to be the same sign as what you see. The +4 stays a +4. And we can see here that not only does it have a vertex of -2, 4 when we look at the graph, but we had talked about how if the leading coefficient is less than 0, we have a downward facing parabola. And you can see that that is the case here. Now, let's talk about parent functions. Parent functions are ones that are the simplest versions of a particular shape. In this case, y equals x squared is the quadratic parent function. That means it is the simplest version of the parabola. You're going to notice that we have some key points, and these are the ones we tend to work with the most. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Those are symmetric about the y-axis, which makes sense because the axis of symmetry for this is x equals 0. And so you always, when you're graphing, want to be centered around your axis of symmetry. So for example, if I had asked you y equals x squared, can you graph that? You would say, okay, well, I know my vertex happens at x equals 0. Okay. And then I have 1, 2 forward, and I have 1, 2 backwards. Notice again, your vertex and axis of symmetry always indicate the center point in your t-chart. So let's say we're given a graph of a quadratic function, and we want to write the equation of that function in general form. We're going to first find any horizontal shift, and that's going to tell us our h. So remember that our vertex is at 0, 0 on the parent function. How much did we shift horizontally to get to the vertex that we have in our graph? Then we had the vertical shift, and that's going to be how much did we shift vertically from 0, 0. These are going to give us our h and our k values. Once you know your h and k values, you're going to be able to substitute them in to the vertex form of our graph. You're going to notice that we have h and k in that form, but we also have an a. So in order for us to figure out what the a value is, we're going to substitute the values in of any point that is not the vertex, because we've already used the vertex, right, to get the h and k. We need some other point, okay? And that's going to allow us to solve for a. Notice that if it opens upward, a will have to be positive or greater than 0. If it opens downward, a has to be less than 0. So always double check that you've given a the correct sign. Then you'll have your a, your h, and your k. You're going to make sure a, h, and k are all plugged in to this green formula up here. And you're going to expand the formula to write in general form. So remember, if they're asking for general form, we want it back in ax squared plus bx plus c format by the time we are done. So let's take a look at this example. Our horizontal shift h, well, remember, I should have a vertex at 0, 0, but I'm really going left 2. So my horizontal shift's negative 2. My vertical shift, I'm really going down 3. So my k is negative 3. Okay, so instead of being at 0, 0, I'm at negative 2, negative 3. And that means that when I go to my vertex form, I'm going to have a x minus negative 2 is really x plus 2 squared minus 3. Now again, I need to find my a value though. So let's go ahead and pick out a point that is on our graph. We like points that involve 0 when possible. So I'm going to pick this point right here, which is going to be 0, negative 1. Okay, so I'm going to say f of 0, a times 0 plus 2 squared minus 3, 1 too many parentheses there, should equal negative 1. Okay, because the point 0, negative 1 is on the graph. So I simplify this. Notice that 0 plus 2 is 2, and 2 squared is 4. So I have 4a minus 3 equals negative 1. 4a is going to equal 2. I divide by 4 on both sides, and I'm going to get a equals 1/2. And that means I can now write f of x equals 1/2 x plus 2 squared minus 3. And this is where I double check. Okay, I have an upward facing parabola. My a value should be positive, which you see that it is. Now, you might be tempted to stop here, and in this case, you're allowed to do that. Why? Well, it said to write the equation of this parabola in vertex form. So that means you get to stop because this is vertex form. When you get to this step, you always want to go back and reread the question and ask what final format they're in. Because in this case, I'm allowed to leave it here. But if they ask me to write it in general form, I would need to do additional steps to get it into the ax squared plus bx plus c format. So let's talk about how do we go from vertex form into general form. So in this case, this is the equation we were just working with. And so let's say that the question said, now we want it in general form. What you're going to do is you're going to FOIL x plus 2 squared. Remember, whenever you square a binomial, you're really writing it out twice and foiling. Then you're going to distribute the 1/2 and combine like terms with the minus 3. Go ahead, take a moment, see how far you can get with that, and then press play once you've given it a try. Okay, so I have equals 1/2 times x plus 2 squared is really, again, the foiling here. Comes out to be x squared plus 4x plus 4. Then I have my minus 3. I'm going to distribute that 1/2. I have 1/2 x squared plus 2x plus 2 minus 3. And that's 1/2 x squared plus 2x minus 1. And so g of x equals this. Notice how I showed my work. Okay, as I went down, I carried the right side down so that what happened was every step I did was equal to the step before. Some things I see a lot of people do is while they're working with the x squared plus 4x plus 4, they don't write the minus 3. But you have to carry the minus 3 down, even if you're not working with it. Same thing with the 1/2. You have to carry those down even though you're not actively using them. Then when you distribute the 1/2, you still have to carry down the minus 3. And when you combine like terms, obviously that minus 3 gets combined with the 2. But if you don't carry those down, then they're technically not equal to one another and you are incorrect in how you're showing your work. So be very, very careful. Make sure this is exactly what you have on your paper. So if you have a quadratic function, first of all, notice that its degree is 2. and its shape is a parabola. We know its general form is ax squared plus bx plus c. We know its standard or vertex form is a times x minus h squared plus k. The vertex hk is located at h equals negative b over 2a, because remember, our axis of symmetry formula for a general form is x equals negative b over 2a, and that's the x coordinate of the vertex. And then to find the vertex, the y coordinate of the vertex, you then plug what you get for the x coordinate, or h, into the function to find the y coordinate. Okay, so remember, this is kind of our key set of information of everything that we've just talked about. So now let's talk about domain and range. We want to find the domain and range of these parabolas. So taking a look at our first graph, you can see we go forever to the left, we go forever to the right. Therefore, our domain is negative infinity to infinity. Our range, however, will not be all real numbers. In this case, we have a slowest point. The absolute lowest point on the graph is 1. So our range starts with 1 and it's included, so we have a bracket. Then we continue upwards forever. That means our highest point is infinity. So our range for this first graph is 1 to infinity. Take a moment and see if you can find the domain and range of our second graph. So here our domain is still going to be negative infinity to infinity, but our range, our lowest point is actually these downward arrows. So it starts at negative infinity and it goes up to our highest point, which is at 4. This is included, so we have a bracket. Notice that range always goes from lowest to highest. If you wrote 4 to negative infinity, you have it backwards and you need to flip that. So let's go ahead and take a look at an application word problem. Here we have a backyard farmer who wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. So we want to find a formula for the area enclosed by the fence if the sides of fencing are perpendicular to the existing fence and have length L. So here, what we're going to do is we're going to find, again, area. We're looking at this area right here. Okay, this is the area of the garden. You can see here that this is a rectangle because they said it was the fencing's perpendicular to the existing fence. So we have area is length times width. Easy enough, right? Well, now we have to figure out what we're going to do to maximize the enclosed area. Because I have 3 sides to this garden, because I already had this side, so I don't need to re-fence that side. So I have L, L, and W. So the perimeter, or the amount of fencing I need, is 2L plus W. How much fencing did they tell us in the problem that she has? Well, they told us we have 80 feet of fence. So 80 equals 2L plus W. Now, how do these two pieces of information combined allow us to solve for part B? What dimensions she should make her garden to maximize the enclosed area? Well, in a problem like this, I want to solve to make the area a quadratic function. In order to do that, I'm going to create my 80 equals 2L plus W. I'm going to make it W equals negative 2L plus 80. By solving for W, I can then substitute that into my area formula. So area equals length times width is now area equals length times negative 2L plus 80. I can distribute my L, which is negative 2L squared plus 80L. And now my area is a quadratic function. In order to find the maximum of this, notice that my leading coefficient is negative. So this is a downward facing parabola, so it does have a maximum. In order to find that maximum amount, remember that's the vertex. So I'm looking for what is the vertex of this equation. So what I'm going to do is I'm going to first find my axis of symmetry. X equals negative b over 2a. In this case, my b is 80, so I have negative 80 over 2 times my a is negative 2. This gives me negative 80 over negative 4, which is going to give me really 20. So what happens here is I know my area is going to be maximized when my length is 20. And so I can also find the value of the area by plugging 20 back in to the area function. So area equals negative 2 times 20 squared plus 80 times 20. Now 20 squared is 400. So when you multiply that by negative 2, you're going to get negative 800. 80 times 20 is 1600. When you add those together, you get 800. So we have that when the length is 20, your area is 800. And remember, you know that it's length and area because look at our formula. We have length is the input and area is the output. So this is L and A. But remember, the question asks, what dimensions should she make her garden? Dimensions here would be length and width. So we know it's 20 feet by something. Now, how do we find the number of feet that it is wide? Well, we plug it into our width equation. Negative 2 times 20 plus 80 is negative 40 plus 80 is 40. So 20 feet by 40 feet will maximize the enclosed area while using all 80 feet of wire fencing. Notice that sometimes these questions will ask for dimensions. Sometimes they will ask you what is the maximum area. Sometimes they'll ask you both. So you do still want to know that the area is 800 square feet. And notice that the unit is square feet. Anytime you have a word problem, you must include the unit. If you don't have a unit on the test, it will dock you points. So be very careful with that. So again, just following through, in case you need a recap, we set our width equal to 80 minus 2L, or negative 2L plus 80. We substituted that in to our length times width formula. We distributed the L, and then we rewrote it, or if you already had it as negative 2L plus 80, we made sure it was in our standard form so that we could then find our intercept, or our vertex. When you look at the graph, you can see that indeed this is going to be the vertex of 800, where 20 is the length, 800 is the area, and you can go back and solve for width with no problem. So now, let's talk about a revenue example. If you are given an application involving revenue, we're going to use a quadratic equation to find the maximum, because of course we want to maximize revenue whenever possible. Revenue is how much money you take in when you're running a business. So of course we want that to be a high number. So you're going to write a quadratic equation for the revenue, find its vertex, and then the y value of that vertex is going to give you the revenue. So take a moment, read through this problem, and see if you can come up with a way to write the equation for the revenue. So a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. Market research has suggested that if the owners raise the price to $32, they would lose 5,000 subscribers. Assuming that the subscriptions are linearly related to the price, what price should the newspaper charge for a quarterly subscription to maximize their revenue? Now, if you got stuck writing a revenue equation here, don't feel too bad. It can be a little tricky. Revenue, again, is how much money are you bringing in, okay? So what you want to do is you want to recognize that revenue is going to be the price of the item times the quantity of items, okay? So a lot of times you'll see it R equals P times Q. So we know here that when we have price, they said that it'll be $30 will get them 84,000 subscribers. But when it's $32, we will lose 5,000 subscribers. That means that we go from 84,000 to 79,000 subscribers when we change that price. And they're telling us price is linearly related. So let's see if we can't find an equation for quantity in terms of price. So notice again, since it's linearly related, that's going to be an important piece. So we know that when the price is $30, we have 84,000 subscribers. When it's $32, we have 5,000 fewer, which is going to be 79,000 subscribers. The slope of the line that goes through these 2 points is going to be negative 5,000 divided by 2, or negative 2,500. So we can say Q minus, let's go with 84,000, equals negative 2,500 times P minus $30. So we use that first point there to put it in point slope form. Then you can distribute your negative 2,500 and add the 84,000 over. Go ahead and give that a try really quickly and see if you can get Q equals in slope-intercept form. Hopefully you got Q equals negative 2,500 P plus 159,000. This is the relationship between price and quantity. Now, why does it help us to have an equation for quantity in terms of price? Well, we can substitute it into our formula for revenue. That allows us to have revenue is price times negative 2,500 price plus 159,000. And then we're able to distribute our P to both. This gives us our quadratic function for revenue. Now, this would be a really great time to practice using your graphing calculator in order to find the maximum revenue. That means that what you want to do is you want to go into your Y1, your Y equals, okay, that button on the top left-hand corner. And then in Y1, you're going to type in negative 2,500 x squared plus 159,000x. Remember, you're using x because that's what your calculator understands. If you put in p, it won't know what to do with it. Then you're going to make sure that you have an appropriate window. So check your window so that you can see the maximum. Okay, and again, remember, it is a maximum because it's a downward facing parabola. Then you're going to go to your second calc menu and choose maximum and follow the instructions. This is going to give you your vertex. Remember, the maximum revenue number is the Y value in this case. So take a couple of moments to work that out. Work with the people around you if you're stuck, but this will be a good graphing calculator practice problem. Hopefully, you were able to get the point 31.80, 2,528.1. Remember, this means our price is $31.80, and if they ask you what is the maximum amount of revenue, you would say $2,528.10. I'm kidding. I just lied to you. You see, I just made the same mistake that people make all the time. What you also want to recognize here is you probably didn't get $2,528.10 because the way that we graphed it here is in the thousands of dollars. So this is really 2,528,100. So $2,528,100 is the maximum revenue. And you see, I'm going to leave this in here for the video so that you can see that I make mistakes too. And hopefully you can say, oh, that makes much more sense. All right, so let's talk about the x-intercepts of a parabola. I've mentioned this before, but this is a good time for us to have a visual. If you have an upward facing parabola above the x-axis, it's going to have no x-intercept. You would also have no x-intercept if you had a downward facing parabola below the x-axis, okay? One x-intercept happens when your parabola touches the x-axis and turns back around. So in other words, the vertex is on the x-axis. And two x-intercepts happen when it crosses the x-axis and then turns around. So these are the three situations that you can have. So remember, if someone asks you for the x-intercepts or the zeros, you can say there are none, there's one of them, or there are two of them. So what I want you to do here is I want you to find both the x and the y-intercepts of this quadratic function. And you can decide, how many you have. And remember, x-intercepts are where it equals 0. Y-intercepts are where you plug in 0. When it equals 0, you can solve by factoring if that's a possibility, if that comes out to a number that works. Or you can solve by quadratic formula. It is up to you unless this question specifies one way or the other. So pause this video, see if you can find the x and y-intercepts. So the y-intercept's the easier one to find, so I'm going to go ahead and start with that. I'm going to plug in 0. That gives me 3 times 0 squared plus 5 times 0 minus 2, which is negative 2. That means my y-intercept is the point 0, negative 2. Again, don't forget to write it as a point. Now the x-intercept, again, you can choose to do this by a quadratic formula or factoring. So if you did it by factoring, you would end up with 3x minus 1 times x plus 2 equals 0, which will give you x equals 1/3 and negative 2. However, let's say factoring where the leading coefficient is not 1 is not your forte, or you've forgotten how to do it. You can, of course, use quadratic formula like we've been doing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Then when we're looking at the square root, 5 squared minus 4 times 3 times negative 2 is 25. And then we have minus 4 times 3 times negative 2 is going to give us plus 24. Now 25 plus 24 is 49. In the denominator we have 6. So now I really have negative 5 plus or minus 7 over 6. So let's take a look at the two numbers that gives us. Negative 5 plus 7 is 2 over 6. And negative 5 minus 7 is negative 12 over 6. So this is 1/3 and negative 2. So you can see that means that our x-intercepts, whether you solve it by factoring or by quadratic formula, is going to be 1/3 0 and negative 2 0. When we look at the graph, you can see that that is indeed the case, and you will have that your y-intercept is the 0, negative 2. So once you have these points, you've almost fully graphed a parabola. I would generally say that you need your vertex and the x-intercepts at least, but the y-intercept is definitely very, very helpful to graphing a parabola by hand. So let's talk about how we can find the x-intercepts by writing something in standard or vertex form, given it in general form. So in this case, we are going to substitute the a and the b values into our h equals negative b over 2a formula. And then we're going to take that number and we're going to plug it into the function to find the k value. So remember, what we've done here is we've now found our vertex. Once we have our vertex, we're going to be able to rewrite the quadratic into vertex form using the h and k, and then we set it equal to 0 to solve for the x-intercepts. Let's see what this looks like in action. Let's say we need to find the x-intercepts of this quadratic function. So what I'm going to do is I'm going to first do h equals negative b over 2a. So in this case, that's negative 4 over 2 times 2. Since 2 times 2 is 4, I have negative 4 divided by 4, which is negative 1. Then my k value is what I get when I plug that h value into the function. So I have 2 times negative 1 squared plus 4 times negative 1 minus 4. That's going to be 2 minus 4 minus 4, which is negative 6. That means my vertex is negative 1, negative 6. So here I can say my f of x is 2, because my leading coefficient's 2, and that's the same in both formats. Okay. Then I have x minus negative 1, which is x plus 1 squared. And then I have plus k, which in this case is minus 6. So I've now put this into vertex form. So once it's in vertex form, it's pretty easy to solve for the x-intercepts, because what you're going to do again is set it equal to 0. To solve this equation, remember you're going to use your traditional order of operations here for solving. You're going to subtract and add first, then divide and multiply, then deal with exponents, and then deal with parentheses. Once you're inside the parentheses, you loop back to the beginning and repeat. Okay, so notice that you cannot work with anything inside the parentheses until you've dealt with everything outside of the parentheses. So this is sometimes called reverse order of operations, or SADMEP, and SADMEP is what you use for solving. So I'm going to start by subtracting and adding. In this case, I'm going to add 6 to both sides. 6 equals 2 times x plus 1 squared. Now I can divide or multiply. In this case, I need to divide by 2. This gives me 3 equals x plus 1 squared. Now I need to deal with the exponent. To get rid of a square and the exponent, I'm going to have to take the square root of both sides. Remember that when you take a square root, you really are going to get plus or minus the square root of 3 in this case. So equals x plus 1. Now that I'm inside my parentheses, I start back at the beginning, which means I'm going to subtract or add if possible. In this case, I'm going to subtract 1. And here you're going to see I'm going to write it as x equals negative 1 plus or minus root 3. You generally want to put the plus or minus in the middle so that you don't forget it. It is also easier to evaluate later if you need to. You can see that this would not have been a very interesting problem to solve by trying to factor, because you're getting an answer that's irrational. It has a square root of 3 in it, which means it is not a whole number answer. When you have these problems, unless specifically told to write it as a decimal, you should not write it as a decimal. You should write it in terms of the radical. Okay, so our x-intercepts, remember, our points are going to be negative 1 plus root 3, 0, and negative 1 minus root 3, 0. Because they are two separate points, you cannot write plus or minus in one single point. You must write it as two separate points as your final answer. So again, just to recap here, for those of you who have a hard time with my handwriting, h equals negative b over 2a gave us negative 1. Then k, we plugged the negative 1 back into the function, and we got negative 6. And then we know that gives us 2 times x plus 1 squared minus 6 as the function. And we set it equal to 0. And when you go to graph this, you will notice that you have these nasty decimals. Those are equivalent to the points we wrote in exact format, but they are rounded. So if you're trying to check your answer using your graphing calculator, you're going to have to take it into account that your answer is not going to be in that decimal format. So you'll have to convert it to double check that they match. All right, I hope that was helpful for y'all. I'll see you in the next video.